Welcome to part 8 of the Trigonometry Basics lecture. So already we identified the trigonometric ratio values at fixed values from 0 to 90. So if you know 0, 30, 45, 60, 90. So I provided a procedure how to find out the values of different trigonometric ratios. For example, if it is a 45 degrees, so the second angle should be also 45, as sum of the triangle in a triangle, sum of the angles will be 180. So therefore, equal sides concept is there. So based on the equal sides, you can find out the hypotenuse, and then you can evaluate the sine A, cos A, tan A, and consequently reciprocals of sine, cos, tan, which is cosecant, secant, cot. Now, if you use the concept of equilateral as two right angle triangles, you can find out the values of 60 as well as 30. So and similarly we can find out 0 and then 90. So I provided the procedure to find out all these fixed trigonometric ratio values at different angles. Now, no, see, so actually you don't need to remember all these angles, because majority will remember these formulas or these angles, but we no need to remember all these angles, no need to remember all these values. Now if you know, if your angle is more than 90, what happens? So let me take, if the angle is in between 0 to 90, it is in quadrant 1. If it is 90 to 180, so then it is in quadrant 2. If it is 180 to 270, then quadrant 3. Then it is, let me take the angle is in 270 to 360, and then 360 to 360 plus 90. So like that you can take the possibilities of angles. Now we know the values of different trigonometric ratios from the 0 to 90, which is quadrant 1. Now what happens in quadrant 2, quadrant 3, as well as in quadrant 4? So let me extend the concept. So how you can identify? Now in case of quadrant 1, so let us draw the right angle triangle where the angle is theta, and we know the opposite side, which is positive, and adjacent side. So now the angle is 90 plus theta. So what happens? It is in second quadrant, or 180 minus theta also you can write. Now if it is 180 plus theta, now it is in quadrant 3. If it is 270 plus theta, then it is automatically is in quadrant 4. Now what happens if you have an expression of sine of 90 plus theta, or some cos of 180 minus theta? Now what I have to do? If it is a 180 plus theta or 270 minus theta, then what I have to do? If it is a 270 plus theta or 360 minus theta, then what I have to do? How I can reduce that expressions of sine 90 plus theta, or what is the value of sine 90 plus theta, or what is the value of cos 180 plus theta, etc. So now I need, instead of remembering the things, I need the certain formulas or certain basic concepts to evaluate all these expressions, right? So let me extend the concept from this table, how I can find the values of the angles which are related to the 90 plus theta or 180 plus theta. Now this is the table. See the table. So in this table you have all the informations of quadrant 1, where 90 minus theta is in quadrant 1 actually, but 90 plus theta or 180 minus theta, which is related to the quadrant 2, right? If we, quadrant 2 actually. And what happens for all six trigonometric ratios? If it is 180 plus theta, 270 minus theta, it is quadrant 3. 270 plus theta, 360 minus theta, it is quadrant 4. 360 plus theta, again it is in quadrant 1. So 90 minus theta is also quadrant 1, and 360 plus theta is also in quadrant 1. Now you have to evaluate to how the sine to cot terms will change. See, so sine is changed to cos, or cos is changed to sine. In some cases it is plus, in some cases it is minus. So how you can find out all these values? So instead of remembering this big table, you have to follow certain basic concepts to find the values of sine 90 plus theta, cos 180 plus theta, etc. Now let me extend the concept. So how you can find the values of such large angles. Now I am taking the two-dimensional quadrant operation, so consisting of four quadrants Q1 to Q4. In case of Q1, both x-axis is positive, y-axis is positive. Now I draw one right angle triangle OPQ where the angle theta is at O, right? Now for this particular triangle, opposite side will be the PQ and adjacent side will be the OQ. Means adjacent side is along the x-axis and opposite side along the y-axis. And the possibility of varying theta is from 0 to, now extend that to up to 90. So therefore the angle is in between 0 to 90. So in quadrant 1 the angle is in 0 to 90. So you can express as 90 minus theta. So that's how we mention. Na? So the theta is in between 0 to 90. Otherwise it is in Q1. Otherwise the theta is 90 minus angle is 90 minus theta. Now here in both, for example, opposite side is along positive y-axis, adjacent side is along positive x-axis. So and hypotenuse is always positive. So all the three sides information is in positive. So sine, if you write opposite side by hypotenuse, so sine positive by positive becomes sine. So even if you write cos adjacent side by hypotenuse, again positive by positive, which is also positive. So similarly tan is opposite side by adjacent side, which is also positive. If these three angles, the main angles sine, cos, tan are positive, obviously their reciprocals cosecant, secant, cot, they are also positive. So all are positive in quadrant 1. Now what happens if it is a quadrant 2? So in case of quadrant 2, now the angle is 90 plus theta to up to 180, right? So the angle is 90 plus theta to 180. Now we will see what happens for the all the trigonometric ratios. So 90 plus theta to or 180 minus theta. So the angle is in between 90 to 180, right? But y-axis is positive, but x-axis is negative. Means opposite side will be the positive, adjacent side will be the negative. Now only opposite side and hypotenuse are positive. So if you write sine, which is opposite side by hypotenuse, am I correct? So right, sine, which is opposite side is positive by hypotenuse is positive. So therefore, which is positive. Similarly, cosecant. Remaining except sine and cosecant remaining involving with only the adjacent side which is a negative, so therefore remaining all are negative. So cos, tan, because tan is the opposite side by adjacent side, so therefore it is also negative, right? So tan is negative and cos negative means secant negative, tan negative means cot negative. So all are negative except sine and cosecant. So this is what happens in quadrant 2. So sine and cosecant are positive, remaining the negative. Now let us extend the angle to the quadrant 3 where it is greater than 180 and less than 270. So 180 plus theta or 270 minus theta. Now it is in quadrant 3. Now here negative x-axis and negative y-axis. Now draw the right angle triangle. So where the both sides will be negative. So only if you express negative by negative, then it will be positive. So if you write sine, which is negative opposite side by hypotenuse is positive, so it is negative. Therefore the sine is negative, cos is negative, cosecant is negative, secant is negative. But if you take tan, which is opposite side by adjacent side, negative by negative becomes positive. So therefore the tan value will be positive. Similarly the cot value is also positive. Now extend the concept to the quadrant 4 where it is the 270 plus theta, angle is 270 plus theta or 360 minus theta. So here y-axis is negative but x-axis is positive, means opposite side is negative, adjacent side is positive. So therefore the cos term and secant term are the positives remaining are negative. So remaining sine, tan, cot, cosecant are negative. In first quadrant, all positive. In second quadrant, sine terms positive. In third quadrant, tan terms. In fourth quadrant, cos terms. Now write this. All silver tea cups. A, S, T, C. So all silver tea cups. That is the form. That is the word we have to remember all these things. But if you follow the concept by looking at the opposite side and negative adjacent side, positive negative information, you can find out which angle, which trigonometric ratio is positive and which trigonometric ratio is negative. So this is how we have to identify the things. Next, in what case sine becomes cos and cos becomes sine, and tan becomes cot and cot becomes tan? Because we have the two possibilities, 190 plus or 90 plus or minus theta, or 270 plus or minus theta. The another angle in another side, 180 plus or minus theta and 360 plus or minus theta. So now we should know when it is positive and when it is negative, right? See, actually in the second quadrant, only the corresponding to the sine terms will be positive, remaining are negative. In third quadrant, tan terms, cot terms positive, remaining in negative. In fourth quadrant, cos related to terms and secant related terms are positive and remaining are negative. But in case of first quadrant, all are positive. The only thing, when it is a 90, sine becomes cos, or when it is a 270, sine becomes cos and cos becomes sine. Now we have to identify when sine becomes cos and cos becomes sine. So it is very simple formula. Adjacent side becomes opposite side and opposite side becomes adjacent side when it is in terms, when the angle is 90 or 270. Otherwise, in case of 180 and 360, it is same. So therefore, only in case of 90 and 270, the information of trigonometric ratios will change from sine to cos and cos to sine. Similarly, tan to cot and cot to tan. And similarly, cosecant to secant and secant to cosecant, only in case of 90 and 270, right? So for other things, the angles will be, the ratios will be same, right? So this is how we can find out the entire, how values from 0 to 360 degrees. We know how to replace the 90 plus theta or 180 minus theta simply in terms of values of sine thetas or cos thetas for a given right angle triangle. Once if you know the two sides again, you can find out whatever the values we can identify.